So just to summarize what's written on the slides, um, we saw that. Oh, so just to summarize what's written on the slides, we figured out how to look at percentage changes in the marginal product of labor and relate them to changes in the amount of workers in agriculture in Japan. And then from that, we used that the wage is equal to the marginal revenue product in whatever output labor is being used to in production to figure out that the percentage change in the wage is just going to be given by the percentage change in the price of that output times, plus the marginal product of labor in that sector. And so the percentage change in the prices of agriculture will go to zero. And so then it's only going to depend, the percentage change in wages is only going to depend on the percentage change of the marginal productivity of labor in agriculture. And so that's going to be given by -1/3 times whatever the percentage change in LA is. From part 9, I showed that LA decreases by 15%. So -3 times 15% is equal to 5%. So let's do the same thing, but now in manufacturing. And I've just rewritten here that we can recall that PM, the price of manufacturing goods, is just going to increase by 10%. So what I'm going to go back to is I'm going to go back to section 4, problem 1, where we derive the marginal productivities of labor and other factors in each sector. And recall that the marginal productivity of labor in manufacturing is just given by 2/3 times AM times T over LM raised to the 1/3. So given what we saw in section 0 about percentage change rules, the percentage change in the MPL in the marginal product of labor in manufacturing is just going to be equal to, we can ignore anything that's not constant. And so note that, for instance, if I just call everything that's constant here C, then I can just rewrite MPLM is equal to C times LM raised to the 1/3. And from here it should be clear, from here it should be clear that from here it should be clear that if I want to go back and look at the percentage change in the marginal product of labor, I can just ignore this constant, pull down this 1/3, and then just need to examine the percentage change in the amount of workers working in manufacturing. Okay, so just to recall, why do we do this? Well, the reason that we do this is because if there's production in a given sector, i.e. there are workers working in that sector, then their wage is just going to be paid their marginal revenue product. And so what is their marginal revenue product? Well, it's just their marginal product of labor, or MPLM, of labor, in manufacturing. So it's just their marginal product of labor in manufacturing times the price of their output. And so that's all this is saying. Okay, and so now, using again these percentage change rules, we know that the percentage change in wages of workers in manufacturing is just going to be given by the percentage change in the price of manufactured goods plus the percentage change in MPLM. Okay, so now we know here that we have that PM increases by 10%, so we can just have that out there. And now all I'm going to do is I'm going to plug in for this in MPLM over here, and so what I should have is I should have that this is now 1/3 times the percent change in LM. Okay, and so recalling what I did in problem 9, you can recall that LM is going to increase by by 15%. And so what does that give me? That gives me 10% times 1/3 times negative 1/3 times 15%, or 10% minus 5%, which ends up giving me 5% overall. So just to confirm, the percentage change of workers in manufacturing is exactly equal to the percentage change of workers in agriculture, which is exactly what we'd expect. So these slides say the exact same thing. And of course, workers are mobile, so if the percentage change in the wage in either industry wasn't the same, they'd just go to the industry that's paying more. And so that can't be the case. Okay, so now moving on to problem 10, part B, what we want to do is we want to depict the labor market equilibrium, the change in prices, and the change in wages graphically. Okay, so on the x-axis, we have the amount of labor that's either going to be employed in in either industry. So here, what we have is, suppose that we have that this distance here, what this is going to represent, that's going to represent the amount of labor employed in manufacturing. This amount of the distance here is going to represent the amount of workers employed in agriculture. And when we open up to trade, this graph is showing that the amount of labor in manufacturing shifts out to LM prime, and the amount of labor in agriculture shifts down to LA prime. Okay, so all we're doing is we're graphing the marginal revenue product of labor. So as I wrote earlier, this is just the marginal revenue product of labor, or sometimes that's written as VMPLA. Okay, and so for instance, note that on the y-axis, we're just graphing the marginal revenue product of labor here on the left-hand side for manufacturing, and on the right-hand side for agriculture. Recall that if we just bring these in and we just go back to what we had in we go back to what we had for the marginal product of labor in each sector, we can recall from before, then what does these expressions become? Well, just going back to what we had, we can note that MPLA is equal to 2/3 times AA times T over LA to the 1/3. Okay. Likewise, okay, so now what I've done is I've just replaced MPLM and MPLA with what we calculated their values were earlier. And you can see that we're going to have that the marginal revenue product of labor, say, let's pick now in manufacturing, well, that's going to be decreasing in the amount of LM. And so we can see that if we're just plotting the marginal revenue product of labor, then initially, if we don't have many workers employed in labor, then that's going to tell us that each worker's value marginal product of labor or marginal revenue product of labor is going to be quite high. Once we start employing more and more laborers in manufacturing, then their marginal revenue product of labor starts decreasing. Okay. Likewise, for the amount of workers employed in agriculture. So initially, if we don't have many workers employed in agriculture, then each worker's marginal revenue product of labor is going to be quite high. And as we start adding more workers, then their marginal revenue product of labor is going to decrease. So the intersection of both industries' marginal revenue product of labor is going to pin down what the wage is going to be. And so note that if the wage for both in both industries wasn't equal, so if one industry had a higher wage than the other, then all of the workers would want to work in one industry or another. So we have to have that in equilibrium, both industries are going to pay the workers the same wage. So initially we have that that wages were equal to W. When we open up to trade, we now the increasing price in manufactured goods causes the value of the marginal product of labor in manufacturing to go up. Why is that? That's because PM increases. And so recall that we said that PM increases by 10%. And so what is this going to do? This is going to increase this curve by 10%. However, when we open up to trade, recall that we said that PA stays constant. And so the marginal revenue product of labor in agriculture, this curve doesn't change. And so now, effectively, the increase in price in manufacturing, which was caused by the opening of Japan to trade, shifts up the value of the marginal product of labor in manufacturing. And so now, again, like before, we reach a new equilibrium where the same wage, which is now 5% higher, which is what we showed earlier, must be paid in both industries. So at this equilibrium, because the wages are higher, we must have had a decrease in the amount of labor employed in agriculture. And so the only way that agriculture is able to pay this higher wage is to hire less workers. So each worker is therefore more productive and produces a higher value of their marginal product of labor. The reason why manufacturing can afford to hire more workers here, they hire an increased amount of labor in manufacturing, is because the price of their output is increased. So hopefully this makes sense, and all of the dynamics of these curves seem straightforward. Basically, to plot these, we just want to go back to their marginal revenue products of labor and see how they change in response to the amount of labor that they employ. So moving on, 10C asks us whether or not workers are going to be better or worse off under trade compared to autarky. And so you can consider that if workers only buy manufactured goods, their real wage is just going to be their wage W divided by PM. What does this tell us? This says that if workers only want to consume manufacturing goods, then W over PM is the total units of manufacturing goods that they can consume given that income W. And so this is sort of stylized, but what W over PM is going to be is going to tell us how many units in total that worker can afford to manufacture goods. And so we call that their real wage with respect to the cost of manufactured goods, or the price of manufactured goods. So now what we're going to do is we're going to evaluate if workers are better off in terms of manufactured goods. So we want to examine the real wage W over PM and how much that's changing. So recall from section 0 that the percentage change of W over PM is just going to be approximated by the percentage change in W, and because PM is in the denominator, it's going to have in effect a coefficient, an exponent of -1, and so we're going to have that change is going to be approximated by the change in W minus the change in PM. We know from before that W has increased by 5% and PM has increased by 10%. And so taking these changes put together, we have that the total change in W over PM is going to be given by -5%. And so what does that tell us? That tells us that workers in Japan, when they open up to trade, can now consume fewer manufactured goods if they only wanted to spend their income on manufacturing goods. Likewise, we can construct the same thought experiment for agriculture. And if workers only wanted to buy agriculture, then their real wage with respect to the price of agricultural goods is W over PA. In essence, what this tells us is if workers spend all of their income on agriculture, what's the maximum number of agricultural goods that they can consume? So that's W over PA. So taking W over PA and examining the change in it, again, the change in W over PA is just going to be approximated by the change in W minus the change in PA. Recall that we said that the price of agricultural goods stays constant, and so that's just going to be 0. And so the only thing that's going to affect the amount that workers can buy of agricultural goods is just their wage, and so that's 5%. And so the amount that workers can now consume more of in terms of spending their income on only agricultural goods, now they can consume 5% more of agricultural goods. So if workers are only buying agricultural goods, they're better off. However, workers we saw earlier are worse off in terms of if they only buy manufacturing goods. And so how do we take these two pieces of evidence at the same time? Well, we can just think about it and realize that most consumers are going to consume both agriculture and manufacturing goods. And so if we don't know what's the precise composition of each worker's grocery basket of both manufacturing goods and agricultural goods, then we're going to conclude that trade is going to have an ambiguous effect on workers in Japan. And we might be able to make a little bit more progress if we make some assumptions about the preferences of workers in Japan, but note that we haven't. And so we don't know the share of income that gets spent on each good. And so with that, we might be able to say a more precise statement. But without that, we just know that depending on their share of consumption of agriculture versus manufacturing, workers in Japan may be better off, they may be worse off. In net, the effect is ambiguous. So what we've done up to now is we've considered the real welfare of laborers. But there are two other types of agents in this model. And so what they're going to be is they're going to be both capital and landowners in Japan. And what we want to do is we want to calculate their percentage change in returns. And so when we want to think about returns, we're going to write that returns to both land and returns to capital. So this is returns to capital. Oh, sorry. Excuse me. The first one is returns to land. Second one is returns to capital. In effect, these are just going to be wages of land plus capital owners, and so they're analogous to the wages given to laborers, but in this case, they're just the wages of land plus capital owners. Okay, so with that out of the way, what we can note is that similar to similar to how workers are paid their marginal revenue product of labor, then for instance, if we think about capital owners, double check, yeah. Sorry, if we think about landowners, then we know that that landowners are paid their marginal revenue product of labor. So what that means is that landowners, their returns to land are just going to be given by the price of the good in which uses their factor. And so only agriculture uses land, and so it's going to be given by the price of agriculture times the marginal product of land. Okay, so then if I want to figure out what the percent change is going to be in the returns to land, it's just going to be given by the percent change in terms of agriculture, in terms of the price of agriculture, plus the percent change in terms of the marginal product of land. So I know already that this is equal to 0, and so the percent change, excuse me, this should say approximated here. The percent change in the returns to land is just going to be approximated by the percent change in returns to land. So now let's go back to what we did in section 4, part 1, and just recall what we had for the marginal product of land. So the marginal product of land is equal to 1/3 times AA times LA to the 2/3 over T to the 2/3 as well. And so if I just separate out all of these terms, I can notice that if I just call these K, that all these terms are going to be a constant. Why are they constant? Well, AA isn't changing. Japan has a fixed amount of land, so T is the fixed amount of land. And so the only thing that's going to matter for the percent change in the marginal product of land is going to be whatever's changing here. And that's just the amount of labor employed in agriculture. That's raised to an exponent of 2/3, so we just pulled that out in front. And so we conclude that the percent change in the marginal product of land is just going to be given by 2/3 times the percent change in labor employed in agriculture. So going back to what I had written, we know that the percent change in land is just going to be given by the percent change in the marginal product of land. And so that's 2/3 LA. Recall that we noted that we said in part 9 that the percent change in LA is just equal to -15%. So plugging that in here, 2/3 times -15% just gives us -10%. And so landowners, their returns have decreased by 10%. Likewise, we can do the same for capital owners. So you can sort of see in advance that we're going to need to know their marginal product of capital. That's just given by 1/3 times AM times K raised to the 2/3. So again, this is all constant because the amount of capital in our economy is fixed. And so the percent change in MPK is just going to be given by 2/3 times the percent change in the labor employed in manufacturing. And so then the percent change in the returns to capital is just going to be given by the percentage change in the price of manufacturing plus the percentage change in the marginal product of capital. Where is that coming from? Well, that comes from that all factors must get paid their marginal revenue product. And so the marginal revenue product is just going to be given by the marginal product of labor, or sorry, the marginal product of capital times the price of the output in the sector in which capital is used, which is manufacturing. So recall that the change in PM, well, we know that PM is going to increase by 10%, and we can just plug in here for MPK, well, that's going to be 2/3 times LM percent. Okay, we know that LM is increasing by 15%, and so in total, this is going to tell us that the percent change in the returns to capital is just 20%. Okay. And so the slides say exactly what I have as well. Okay, so let's move on to part 10E.